Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. In this video, we'll introduce you to Amazon Keyspaces, a fully managed serverless database service built for scalability, high availability, and compatibility with Apache Cassandra. We'll explore the key architectural concepts, deployment models, consistency mechanisms, and best practices for designing and monitoring your Keyspaces tables. Let's get started. Amazon Keyspaces is a fully managed serverless database service that brings the power and flexibility of Apache Cassandra to the AWS cloud. If you've worked with Cassandra before, you know it offers excellent scalability and performance, but managing clusters, tuning throughput, and handling replication can quickly become operationally complex. Keyspaces removes that burden entirely. Amazon Keyspaces supports the Cassandra Query Language, or CQL, which means you can migrate existing Cassandra workloads or build new applications using familiar tools, libraries, and drivers, all without rewriting code. It's a drop-in solution that simplifies operations while maintaining compatibility with the Cassandra ecosystem. Designed from the ground up as a serverless service, Keyspaces automatically scales to meet your application's throughput and storage demands. There's no need to provision capacity or manage infrastructure. You just focus on your data model and queries, and Keyspaces handles the rest. This results in both consistent performance and cost efficiency, regardless of scale. Under the hood, it runs on AWS's highly resilient multi-AZ infrastructure. Data is automatically replicated across 3 availability zones within a region, providing built-in durability and fault tolerance. Whether you're supporting mission-critical enterprise applications or high-volume consumer workloads, Keyspaces delivers the availability and reliability you expect. And with its support for low latency reads and writes, flexible schema design, and high write throughput, Amazon Keyspaces is ideal for use cases like time series data, IoT telemetry, real-time messaging, and recommendation engines. Wide column NoSQL databases follow a fundamentally different design philosophy compared to traditional relational databases. Rather than beginning with a normalized, schema-first model, table design in wide column databases is built around how the data will be queried. This query-first approach means you design tables by identifying your access patterns up front and structuring the data to optimize for those specific queries. This model enables extremely efficient reads, as it eliminates the need for complex joins and minimizes the number of nodes or partitions accessed during a query. The result is predictable, low-latency performance even as data scales into terabytes or petabytes. Unlike in relational databases, referential integrity is not enforced within wide column systems. Instead, relationships between entities are typically managed at the application level. Data duplication is not just tolerated, it's often encouraged to enable faster reads and avoid costly operations like joins or secondary lookups. Wide column NoSQL databases are also optimized for write-heavy workloads, making them ideal for scenarios like telemetry ingestion, event logging, real-time metrics, and time series data, where high-volume concurrent writes are the norm. To ensure data durability and consistency in a distributed environment, consistency settings play a crucial role. For instance, in systems like Apache Cassandra, a combination of consistency level equals quorum and replication factor equals 3 can provide strong consistency, requiring a majority of replicas to acknowledge read or write operations. This strikes a balance between availability and data correctness, depending on the needs of your application. Amazon Keyspaces is built on a serverless architecture that fully abstracts away cluster and infrastructure management. There are no nodes to provision, scale, or maintain. Users interact only through CQL, while Keyspaces handles the heavy lifting behind the scenes. At its core, Keyspaces features decoupled compute and storage layers, allowing it to elastically scale based on demand. This separation enables consistent performance and seamless scaling without the need for over-provisioning. To ensure high availability and data durability, Keyspaces automatically replicates all data across 3 availability zones within an AWS region. This multi-AZ architecture ensures that the service remains resilient even in the event of zone-level failures. Data is partitioned using hashed partition keys, which distributes the load evenly across the underlying infrastructure. This partitioning strategy is crucial for achieving consistent, low-latency performance at scale. When a client issues a CQL query, it is routed through a stateless request routing layer, which efficiently maps the query to the appropriate storage partition based on the partition key. This design supports horizontal scalability and simplifies request processing. Underneath, Keyspaces stores data in an append-only format, similar to Cassandra's SS table storage engine. This format enables high write throughput and fast, efficient reads, which are essential for time series, event-driven, and telemetry workloads. This diagram provides a high-level view of the internal architecture of Amazon Keyspaces and how it handles requests within an AWS region. On the left-hand side, we see three different entry points for interacting with Amazon Keyspaces: the Keyspaces console, Cassandra-compatible drivers, and CQLSH, the command line shell for executing CQL commands. These all connect to the fully managed Amazon Keyspaces service. Once a request reaches Amazon Keyspaces, it is routed through a stateless request router layer. This layer is designed to be highly scalable and distributed, ensuring that each incoming query, whether it's a read or a write, is efficiently directed to the appropriate storage partitions. The request router abstracts away all cluster-level management, so developers don't have to worry about node maintenance, cluster tuning, or availability zone failures. Behind the scenes, data is stored in a fully decoupled storage layer, which is replicated automatically across three availability zones within the same AWS region. Each availability zone contains multiple partitions of data, ensuring high availability, fault tolerance, and data durability. This replication model guarantees that your data remains accessible even if one or two availability zones become temporarily unavailable. The storage is partitioned based on a hashed partition key, enabling uniform data distribution and predictable performance at scale. Data is stored in an append-only format, much like Cassandra SS tables, which supports high-throughput writes and fast, consistent reads. Amazon Keyspaces provides tunable consistency levels, allowing developers to make informed trade-offs between consistency, availability, and performance, just like in Apache Cassandra. You can configure these levels independently for read and write operations using your client drivers, such as the Cassandra Java driver, Python, Cassandra driver, or AWS SDKs. Among the supported levels are Local 1, Local Quorum, and All. These consistency settings determine how many replicas must respond to a read or write operation before it's considered successful. For strong consistency, the recommended choice is Local Quorum. It ensures that a majority of replicas within a single AWS region have acknowledged the read or write, providing a reliable balance between consistency and high availability. This is often the default in production workloads. At the strictest end of the spectrum is consistency level is set to all. In this mode, all replica nodes must respond successfully to a read or write request for it to be accepted. This guarantees the strongest possible consistency, no stale data, no divergence, but at the cost of higher latency and reduced availability. If even one replica is unavailable or slow to respond, the operation fails. While all ensures absolute correctness, it's rarely used in practice, except for extremely critical updates where data correctness outweighs all other considerations. Under the hood, Amazon Keyspaces automatically handles data replication across three availability zones, enforcing these consistency guarantees without requiring you to manage node placement, token ranges, or cluster repairs. Finally, it's important to note that Keyspaces operates within a single region and does not offer native cross-region consistency. If global consistency is a requirement, additional architectural considerations outside Keyspaces are necessary. Provisioned capacity mode in Amazon Keyspaces gives you fine-grained control over your application's throughput by letting you explicitly define the number of read and write capacity units, known as RCUs and WCUs, for your tables. This mode is designed to deliver predictable performance and pricing by allocating a fixed amount of throughput in advance. You're billed based on this provisioned capacity, regardless of whether it's fully utilized or not. One of the key advantages of this approach is cost predictability. Since you're provisioning a known quantity of resources, it's easier to budget for database usage over time, making this model ideal for workloads with steady or predictable traffic patterns. Although the throughput is fixed, provisioned capacity mode can still accommodate changes in workload through auto-scaling. When enabled, auto-scaling monitors traffic patterns and adjusts capacity up or down within defined limits to help maintain performance and optimize costs, reducing the need for manual intervention. This mode is particularly well suited for mature applications where usage trends are stable and throughput requirements are well understood, such as production systems with consistent traffic, reporting workloads, or back-end services with SLAs that demand consistent performance. However, it's important to be aware of scaling limits. Since there are restrictions on how quickly provisioned capacity can scale up per minute, sudden spikes in traffic beyond your allocated capacity may lead to throttling, potentially impacting application performance until traffic subsides or capacity is increased. In on-demand capacity mode, Amazon Keyspaces offers a truly hands-off experience when it comes to managing throughput. Instead of provisioning read and write capacity ahead of time, Keyspaces automatically scales to meet your application's workload in real time. Whether your traffic surges unexpectedly or remains idle for long periods, the system adjusts seamlessly without requiring any manual tuning. This mode is particularly cost-efficient for applications with variable or unpredictable traffic. You're only billed for the actual read and write operations performed, rather than for reserved capacity. That means no over-provisioning and no paying for unused throughput, a major advantage for workloads that have inconsistent usage patterns or experience sudden spikes. Another big benefit of on-demand mode is the elimination of capacity planning altogether. Developers and architects no longer need to guess or monitor usage trends to tweak performance. The system takes care of scaling for you, automatically and instantly. This makes on-demand capacity an ideal choice for use cases such as new application launches, proof-of-concept workloads, seasonal traffic spikes, or unpredictable workloads like IoT ingestion or user-generated content. However, it's important to note that for steady, predictable traffic patterns, this mode may not always be the most cost-effective. Since you're charged per request, applications with high, consistent usage might benefit from the cost predictability of provisioned capacity instead. But for flexibility, simplicity, and performance at scale, on-demand capacity delivers a robust and dynamic solution. Amazon Keyspaces is built with security at its core, offering comprehensive, built-in encryption mechanisms that protect your data both at rest and in transit, without any additional configuration or overhead for developers. Encryption is turned on by default, and it's completely transparent to applications, meaning you don't need to modify your code or change how your clients interact with the database to benefit from robust encryption. All data stored in Keyspaces is automatically encrypted at rest using the AWS Key Management Service, KMS. By default, AWS managed KMS keys are used to protect your data. However, for organizations that require tighter control over key management, you can opt to use customer-managed KMS keys. This allows for more granular control over who can use the keys, how they're rotated, and how their usage is logged, offering deeper auditability and compliance alignment. To protect data in motion, Keyspaces enforces encryption using transport layer security, TLS, specifically TLS 1.2 or higher. This ensures that all communication between your applications and the Keyspaces service is encrypted using industry-standard protocols, helping meet stringent regulatory and compliance requirements like HIPAA, SOC 2, and more. What's especially important is that this security does not come at the expense of performance. The encryption is optimized to run with minimal overhead, so you still get the high-throughput, low-latency reads and writes that wide-column workloads demand. For even more precise control over data access, Keyspaces allows you to define fine-grained permissions by combining AWS IAM policies with KMS key policies. This dual-layered approach enables you to restrict who can access tables or perform operations down to specific actions, and even time-bound or condition-based constraints. Amazon Keyspaces is engineered from the ground up for high availability, fault tolerance, and resilience, making it a robust choice for mission-critical, always-on applications. At the core of its architecture is built-in multi-AZ replication. Every piece of data written to Keyspaces is automatically replicated across three separate availability zones within a single AWS region. This ensures that your application can continue to perform read and write operations seamlessly, even in the event of one or even two AZs going offline. This architectural resilience is backed by a strong SLA of 99.99% availability, aligning with enterprise-grade expectations for reliability and uptime. Beyond replication, Keyspaces also separates the control plane and the data plane for increased operational stability. The control plane is responsible for managing the overall service configuration. Things like creating keyspaces, defining tables, applying security settings, and provisioning resources. In contrast, the data plane is where all the real-time action happens, storing, retrieving, and updating data via SQL queries. This separation ensures that administrative tasks and live data operations do not interfere with each other, contributing to consistent performance and improved fault isolation. To avoid any single point of failure, Keyspaces uses stateless request routing and distributed data partitioning. When a request comes in, it is dynamically routed to the appropriate partition, an AZ based on the hashed partition key. This intelligent routing ensures that requests are always directed to healthy, responsive parts of the infrastructure, further enhancing availability and performance. Finally, depending on whether you're using provisioned or on-demand capacity mode, Keyspaces automatically scales its throughput and storage to match your workload. In provisioned mode, auto-scaling can adjust capacity based on usage patterns, while on-demand mode offers seamless scale-up and scale-down based entirely on demand. This elasticity means your applications stay responsive, even during traffic spikes, without requiring any manual intervention or infrastructure tuning. Amazon Keyspaces is designed with operational resilience in mind, and its backup and restore capabilities are a core part of that strategy. By enabling point-in-time recovery, or PIR, for a table, you unlock continuous, automatic backups that happen seamlessly in the background with absolutely no impact on application performance. There's no need to pause reads or writes, and your tables remain fully available 24/7, even as backups are created in real time. With PIR enabled, you can restore your table data to any specific second within the past 35 days. This level of granularity is invaluable in scenarios like accidental data deletion or corruption, where you may need to roll back to a very precise point in time. Better still, restores are scoped to individual tables, giving you fine-grained recovery without disturbing the rest of your database. In addition to PIR, Amazon Keyspaces integrates natively with AWS Backup, a powerful centralized service that automates and orchestrates backup operations across AWS services. This integration allows you to define backup schedules, lifecycle policies, and retention rules, all from a single control plane. Security and compliance are also built into the backup workflow. Access to backup and restore operations is managed through IAM policies, ensuring only authorized users can perform sensitive operations. AWS Backup also supports cross-region backup copies, allowing you to replicate backups to other AWS regions for disaster recovery, regulatory compliance, or long-term archival storage. Together, these features give you the tools to protect your data with confidence, recover quickly when needed, and meet even the strictest business continuity and compliance requirements, all without adding operational overhead. Amazon Keyspaces offers a powerful set of monitoring capabilities that allow you to gain deep visibility into your workloads, optimize performance, and ensure operational health. These capabilities are built around seamless integration with AWS's native observability stack, giving you the tools to monitor everything from real-time latency to historical usage patterns. At the core of this is Amazon CloudWatch, which provides native table-level metrics for Keyspaces. You can monitor key performance indicators like read and write latency, consumed throughput, RCUs and WCUs, and throttle events, all in real time. These insights allow you to track how your application is performing under various loads. CloudWatch alarms can be configured to notify your team instantly when certain thresholds are breached, helping you respond proactively to issues before they escalate into outages. To help identify performance bottlenecks, CloudWatch Contributor Insights can analyze your Keyspaces traffic and surface high cardinality data points, such as hot partitions or uneven access patterns, allowing you to fine-tune your schema or capacity model accordingly. For easier visualization and centralized monitoring, you can build custom CloudWatch dashboards tailored to your team's specific KPIs and operational metrics. Complementing CloudWatch is AWS CloudTrail, which records every API interaction with Amazon Keyspaces, whether it's table creation, access control changes, or schema updates. This detailed audit trail is critical for maintaining compliance, conducting security forensics, and gaining full transparency into who did what and when. Beyond these core services, Amazon Keyspaces also supports tag-based monitoring. You can organize resources and metrics by tags such as application name, team, environment, or cost center. This tagging strategy helps with access control, billing attribution, and simplifying observability across large environments. Finally, Keyspaces integrates well with other observability tools, including AWS X-Ray for distributed tracing, CloudWatch logs for log aggregation, and even third-party solutions like Datadog, New Relic, or Splunk, giving you a comprehensive end-to-end view of your database activity as part of your larger system architecture. Migrating to Amazon Keyspaces from an existing Apache Cassandra deployment allows you to offload the operational overhead of managing clusters while preserving application compatibility through the use of Cassandra Query Language, CQL. Whether you're looking to simplify operations, improve scalability, or enhance availability, Keyspaces offers a fully managed, serverless alternative. This migration can be achieved through various strategies, ranging from straightforward table-based bulk migrations to more complex dual-write patterns for near-zero downtime transitions, allowing you to choose the approach that best fits your application's needs and tolerance for disruption. Table-based migration, often referred to as bulk load migration, is one of the simplest and most efficient ways to move data from an existing Apache Cassandra environment to Amazon Keyspaces, particularly well suited for offline or low traffic use cases. This approach is ideal when you can schedule a maintenance window or tolerate brief downtime during the transition. The process typically involves exporting your Cassandra data using tools like SS Table Loader, the AWS Schema Conversion Tool, SCT, or custom-built scripts. These tools allow you to extract existing tables and load them into Amazon Keyspaces with minimal rework, especially since Keyspaces supports the Cassandra Query Language, CQL, allowing much of your existing schema to be reused as is. During the cutover window, applications are paused or rerouted while the final data transfer takes place, ensuring consistency between your source and target databases. This method offers a clean switchover path and is particularly useful when migrating legacy workloads or consolidating Cassandra clusters without the complexity of managing a live, bidirectional sync. The dual-write migration strategy is designed for live systems that require minimal to zero downtime during the transition from Apache Cassandra to Amazon Keyspaces. In this approach, your application is modified to write data simultaneously to both the existing Cassandra cluster and the new Keyspaces environment. This ensures that the data in both systems stays in sync during the migration period. While dual writes are active, read operations continue to be served from the original Cassandra database, ensuring application continuity without impacting performance. This parallel operation allows teams to thoroughly test and validate the data and performance on Amazon Keyspaces without disrupting the production environment. Once confidence is established in the Keyspaces setup, through functional validation, performance benchmarking, and consistency checks, you can seamlessly switch your application's read operations to point to Keyspaces. After confirming full operational parity, the legacy Cassandra infrastructure can be safely decommissioned, completing the migration with little to no user-visible disruption. This approach, along with table-based migration options, enables a flexible and reliable path for transitioning your workloads to Amazon Keyspaces, bringing the benefits of a fully managed, serverless Cassandra-compatible database without disrupting existing operations. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. And thank you for watching.